Southwire MC Smart System represents a notable advancement in metal-clad cable technology. It is designed to use the cable jacket itself as the equipment grounding conductor, which removes the necessity for a separate grounding wire. This innovation results in time and cost savings during the installation process. The grounding path is protected by the cable jacket, providing a more reliable grounding path than a separate grounding wire, which can be damaged during installation or over time. Firstly, eliminating the separate grounding wire simplifies the installation process, reducing the amount of material and labor required. Secondly, the integrated grounding system offers enhanced reliability. The cable jacket provides a robust and protected grounding path, less susceptible to damage compared to a separate wire. Thirdly, the system meets all National Electrical Code requirements for metal-clad cable. The MC Smart System is listed to Underwriters Laboratory Standard 1569 and complies with all relevant NEC stipulations. Fourthly, this cable is available in various sizes and configurations to suit diverse application needs. The Southwire MC Smart System finds applications across a broad spectrum of construction and industrial settings. It is particularly well suited for commercial buildings to power lighting, heating, ventilation, and air conditioning systems, and other electrical equipment. It is also beneficial in industrial buildings for powering machinery and various industrial systems. Furthermore, the MC Smart System is designed for healthcare facilities, providing a reliable power source for medical equipment, lighting, and other essential systems. Installation of the MC Smart System involves a few key steps. 1. Cut the cable to the required length. 2. Remove the cable jacket from the ends of the cable to expose the conductors. 3. Connect the conductors to the electrical device being powered. 4. Secure the cable in its final position, ensuring proper support and protection. Regarding technical specifications, the MC Smart System offers several options. The conductor material can be either copper or aluminum depending on the specific requirements. The insulation is made of cross-linked polyethylene, also known as XLPE, providing excellent electrical and thermal properties. The cable jacket is constructed from polyvinyl chloride, known as PVC, which offers durability and resistance to environmental factors. The grounding path is achieved using a number 10 American wire gauge aluminum bare conductor position between the mylar layer and the armor. The voltage rating for the MC Smart System is 600 volts, suitable for a wide range of applications. The temperature rating is 90 degrees Celsius, indicating the maximum operating temperature of the cable. The MC Smart System is listed to Underwriters Laboratory Standard 1569, ensuring compliance with safety and performance standards. When ordering the MC Smart System, several factors need consideration. Firstly, cable size must be specified. The system is available in various sizes including number 14 American wire gauge, number 12 American wire gauge, number 10 American wire gauge, number 8 American wire gauge, and number 6 American wire gauge. Secondly, the number of conductors needs to be specified. Options include 2, 3, 4, or 5 conductors. Thirdly, the required length of the cable should be indicated. The MC Smart System is available in various lengths to accommodate different project requirements. Fourthly, the jacket color can be chosen. The system is available with either a black or a white jacket. The core principle behind using the cable jacket as the equipment grounding conductor lies in the physics of electrical current flow and the design of the cable. In an electrical system, the equipment grounding conductor, often referred to as the EGC, provides a low impedance path for fault current to return to the source, typically the electrical panel or transformer. This low impedance path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, which disconnect the power supply in the event of a fault, preventing electrical shock and fire hazards. In conventional metal-clad cable designs, a separate green insulated copper wire serves as the equipment grounding conductor. This wire runs alongside the current carrying conductors within the cable assembly. The MC Smart System deviates from this traditional design by utilizing the metallic jacket of the cable itself as the primary equipment grounding conductor. The metallic jacket, typically made of aluminum, provides a continuous conductive pathway along the entire length of the cable. This pathway is electrically connected to the metal enclosures or equipment that the cable is feeding. When a fault occurs, the fault current flows through the metallic jacket back to the source. The key advantage of this design is the low impedance of the metallic jacket compared to a separate grounding wire. The larger cross-sectional area of the jacket provides a lower resistance path for the fault current, resulting in faster clearing of the fault. The inclusion of a number 10 American wire-gauge aluminum bare conductor between the mylar layer and the armor further enhances the grounding performance. This conductor acts as a supplemental grounding path, augmenting the conductivity of the metallic jacket. The mylar layer provides electrical insulation between the aluminum conductor and the metallic armor, preventing any unwanted current flow under normal operating conditions. The overall design of the MC Smart system ensures a robust and reliable equipment grounding system. The continuous metallic jacket, combined with a supplemental aluminum conductor, provides a low impedance path for fault current, contributing to improved electrical safety. From an engineering perspective, the design of the MC Smart system involves careful consideration of several factors, including the conductivity of the jacket material, the thickness of the jacket, and the contact resistance between the jacket and the metal enclosures or equipment. The conductivity of the jacket material is a crucial parameter as it determines the resistance of the grounding path. Aluminum is a commonly used material for MC cable jackets due to its high conductivity, lightweight, and corrosion resistance. The thickness of the jacket also influences the grounding performance. A thicker jacket provides a larger cross-sectional area for current flow, reducing the resistance of the grounding path. The contact resistance between the jacket and the metal enclosures or equipment is another important consideration. Proper termination techniques and the use of appropriate connectors are essential to minimize contact resistance and ensure a reliable electrical connection. The NEC sets forth specific requirements for equipment grounding conductors, including minimum size and ampacity. The MC Smart system is designed to meet or exceed these requirements, ensuring compliance with electrical safety codes. The NEC mandates that the equipment grounding conductor must be sized appropriately to handle the available fault current. The size of the grounding conductor is typically based on the size of the overcurrent protective device protecting the circuit. The NEC also requires that the equipment grounding conductor be continuous and effectively connected to the metal enclosures or equipment. This ensures a reliable grounding path throughout the electrical system. The MC Smart system offers several advantages over traditional MC cable designs in terms of grounding performance, installation efficiency, and overall cost. Firstly, the integrated grounding system eliminates the need for a separate grounding wire, reducing material costs and installation time. Secondly, the continuous metallic jacket provides a low impedance grounding path, resulting in faster clearing of faults and improved electrical safety. Thirdly, the MC Smart system is designed for ease of installation. The cable can be easily cut, stripped, and terminated using standard tools and techniques. Fourthly, the MC Smart system is available in a variety of sizes and configurations to suit diverse application needs. When selecting MC cable for a particular application, it is important to consider several factors including the voltage rating, ampacity, environmental conditions, and the type of equipment being powered. The voltage rating of the cable must be equal to or greater than the voltage of the circuit. The ampacity of the cable must be sufficient to carry the load current without overheating. The cable must be suitable for the environmental conditions in which it will be installed. For example, if the cable will be exposed to moisture or corrosive substances, it must be rated for wet or corrosive environments. The type of equipment being powered may also influence the choice of MC cable. For example, some equipment may require shielded cable to minimize electromagnetic interference. In addition to the MC Smart system, Southwire offers a comprehensive range of other wire and cable products for various electrical applications. These products include building wire, flexible cords, power cables, and specialty cables. Southwire's building wire is used for a wide range of residential, commercial, and industrial wiring applications. The company's flexible cords are used for connecting portable appliances and equipment. Southwire's power cables are used for transmitting electrical power over long distances. The company's specialty cables are designed for specific applications such as data transmission, control systems, and instrumentation. Southwire is a leading manufacturer of wire and cable products committed to providing high-quality, reliable, and innovative solutions for the electrical industry. The company's products are used in a wide range of applications, from residential wiring to industrial power distribution. The MC Smart System represents a significant advancement in metal-clad cable technology, offering improved grounding performance, installation efficiency, and overall cost savings. This innovative cable system is well suited for a variety of applications, including commercial buildings, industrial facilities, and healthcare facilities. When working with electrical systems, it is essential to follow all applicable safety codes and regulations. Only qualified electricians should perform electrical work. Always to energize circuits before working on them. Use appropriate personal protective equipment such as gloves and safety glasses. Inspect tools and equipment regularly to ensure they are in good working condition. Never work alone on electrical systems. Electrical safety is paramount. Adhering to safety protocols and employing qualified professionals ensures the integrity and safety of electrical installations.